Hello, today we're going to be doing LeetCode problem 345, which is reverse vowels of a string. This problem states, given a string S, reverse only all the vowels in the string and return it. The vowels in question are A, E, I, O, and U, and they can appear in both lower and upper cases more than once. So example 1, input is hello, so basically we're just going to replace the O and the E, and that's what you see in the output. LeetCode, we're going to replace the E's and we're going to replace the E with the O. So the way we're going to do this is to use 2 pointers. This is very similar to LeetCode problem 344, which is reverse a string. Only this time we're only concerned about the vowels. So the first thing we're going to do is convert that string into a char array. So let's create the pointers. So we'll call this one the left pointer. We're going to initialize that to 0, and then we'll have a right pointer. We're going to initialize that to s length -1. And then we need to create a string of vowels. This is what we're going to be comparing the letters to. A, E, I, O, U, A, E, I, O, U. Alright, so now we have everything defined. So we're going to do while left is less than right. So this is going to traverse through the entire character array, and at the very end of everything we need to increase left to move the pointer, and then we need to decrement right. Alright, so what we want to do here is basically skip over the consonants. So while we're going to do this, while left is less than right. And why are we doing this again? Basically, if you don't have any vowels, this will just go on forever. So you have to make sure left is less than right to break out of it. And vowels index of word left equals -1, meaning it did not find a vowel because it's not in the string vowels. Vowels index on. So all we're going to do basically is increment left. I'm going to copy this because we have to do the same thing with right. And we're going to make right. Okay, so this will get rid of the first consonants on the left side of the string, and this will get rid of the characters on the right, the first character on the right side of the string. So if we get through all that, then we have found our first vowel at left and our first vowel at right. So now we just need to do the old switcherooski. So we're going to assign a temp value to left, then we're going to make word left equal to word right, which will switch that letter. And then we need to make the character at position right equal the temp value. Left, right, left, right. And at the end here we just need, so now we have switch word around. So we need to return new string word. Alright, let's see what I messed up here. Both cases were accepted. Let's submit it, and that was also successful. So let's debug this quick. Using the first example, we see S is hello, the word array is hello. We converted that to characters. Left is 0, right is 4. We define our string value. All right, left is less than right, which is true. So while left is less than right and vowels index word left is equals -1. So the first thing it's going to look at is the H, and it sees that the H is not a vowel. So it's going to go back again. Left is still less than right, and we came to the E. So the index of word left would not be equal to -1. So we found the E. Now we need to do the same thing with the right. And we found the O. So index word right was not equal to -1. So now we're just going to switch these two. Temp, left is right, right. So now you can see on the left here, word is, we left the H alone, but we switched the E and the O. Now increment, decrement. So now left is 2 and right is 3. So we're still here. Now we come here and we've got the L. Now we do it again. And left is not less than right. It's equal to right. So now we do the same thing. And we skip that because left is 3 and right is 3. So now we're just going to switch. This is basically just going to not do much because we don't have any vowels left. We only had a consonant left, so when it fell through and tried to switch a consonant, but it was only one letter left, so it switched it, but not really. Increment that, decrement right, and now left is not less than right, so then we just return the string. Output holy. All right, so the time complexity of this problem is O of n. The only way you're going to take more time is if your input string is larger. And space complexity is the same thing. The only way you're going to use more memory is if you have a larger string. And that is it. So thanks so much for watching. I hope you learned something, and we'll see you next time.